When I first started studying neuroscience, I was absolutely fascinated by what happens in our brains while we sleep. And recent research has completely blown my mind about how sleep actually shapes the way we make financial decisions. So let me share with you some incredible discoveries that came out just this year from Nature Neuroscience. What they found is that during those deep sleep phases, your brain is literally rewiring itself. There's this amazing dance happening between your hippocampus and your neocortex where memories are being transferred and consolidated in ways we never fully understood before. Here's what's really cool about this process. Your brain has these special oscillatory events. Think of them like perfectly timed waves called sleep spindles and sharp wave ripples. When these waves sync up, something magical happens. Your NMDA receptors activate, calcium flows into your neurons, and new proteins start building stronger connections between brain cells. Now, here's where it gets really interesting for anyone thinking about money and financial decisions. Your prefrontal cortex, that's your brain's CEO, if you will, starts forming stronger connections with areas that handle emotions and risk assessment. It's like your brain is upgrading its financial decision making software while you sleep. But wait, there's more? And this is where the research gets really exciting. Scientists have discovered that specific sound frequencies can actually influence this whole process. I'm talking about neural entrainment. Basically, your brain can sync up with external rhythms. The 528 hertz frequency that many people talk about? Well, it turns out there's real science behind it. Research from the Journal of Neuroscience shows that this frequency can create what scientists call cross-frequency coupling. Imagine your brainwaves as different instruments in an orchestra, and this frequency helps them play in perfect harmony. When researchers used high-density EEG arrays, that's like having hundreds of tiny microphones listening to your brain, they found that exposure to specific frequencies during sleep actually increased communication between your frontal and parietal regions. These are the areas responsible for executive function and attention. Pretty amazing, right? Now, let's talk about how your brain actually makes financial decisions because this is where the science gets really practical. Your brain has these incredible networks that work together like a well-coordinated team. First, there's what we call the default mode network. Think of this as your brain's daydreaming mode, but it's actually doing something incredibly important. It's constantly simulating future scenarios and helping you plan ahead. During sleep, this network becomes super active, potentially helping you become better at strategic thinking. Then you have the salience network, which is like your brain's emotional intelligence center. It's constantly evaluating what's important and what's not, especially when it comes to money and opportunities. Sleep seems to fine-tune the system, making you better at recognizing truly valuable opportunities. And finally, there's the executive control network, your brain's project manager. This network handles working memory and helps you stay flexible in your thinking. When this network is optimized through better sleep, you literally become better at complex financial reasoning. What's fascinating is that brain imaging studies show people with optimized sleep patterns have much stronger connections between all these networks. It's like having a high-speed internet connection between different parts of your brain instead of dial-up. Now, let's dive into the architecture of sleep itself because understanding this can really help you optimize your own cognitive performance. Sleep isn't just one thing, it's actually a carefully orchestrated series of stages, each serving a specific purpose. During stage 2 non-REM sleep, your brain generates these things called sleep spindles. Picture them as protective shields that block out distractions while your brain transfers important information from temporary storage to permanent memory. These spindles happen at about 12 to 14 cycles per second, and they're absolutely crucial for learning. Then comes slow wave sleep, where your brain produces these big, slow delta waves. This is when the really heavy-duty memory consolidation happens. But here's something most people don't know. During this stage, your brain also activates its cleaning system, called the glymphatic system. It's literally washing away metabolic waste that could impair your thinking. REM sleep is where things get creative. Your brain starts making random connections between different pieces of information, which is why you might wake up with a brilliant solution to a problem you've been struggling with. The chemical environment during REM sleep seems to promote this kind of innovative thinking. All of this is controlled by your body's master clock, the suprachiasmatic nucleus. When this timing system gets disrupted, the whole beautiful process of sleep-dependent learning can fall apart. Here's what's really exciting about current research. Scientists are developing targeted interventions that can enhance specific aspects of this process. For example, they can place certain sounds during slow wave sleep to boost memory consolidation, or use different techniques during REM sleep to enhance creative problem solving. But I want to be completely honest with you about where the science stands right now. While the research is incredibly promising, we're still learning about the best ways to apply these findings. Many studies are still correlational, meaning we can see relationships but can't always prove direct causation. The field is moving toward developing closed loop systems that can monitor your brain in real time and deliver personalized interventions. Imagine having a device that knows exactly when you're in the optimal sleep stage and can enhance your brain's natural processes at just the right moment. We're also seeing incredible advances in brain imaging technology that are giving us unprecedented views into how sleep affects cognition. And animal studies using optogenetics, where scientists can control specific brain cells with lights, are revealing the precise mechanisms behind sleep dependent learning. From a practical standpoint, this research could revolutionize how we think about cognitive enhancement and even cognitive rehabilitation. But we also need to carefully consider the ethical implications of these technologies. What I find most exciting is that we're standing at the edge of a new era in understanding the relationship between sleep, learning, and human potential. The more we learn, the more we realize that optimizing our sleep might be one of the most powerful tools we have for enhancing our cognitive abilities and decision-making skills. And the beautiful thing is, this all happens naturally every single night in the amazing 3-pound universe inside your head.